Hi guys, welcome to this very interesting problem on my copy. The problem is find the minimum value of root of a square plus b square plus root of a square minus 4a plus 4 plus b square plus root of a square plus b square minus 6b plus 9 plus root of a square minus 8a plus 16 plus b square minus 10b plus 25. This is a problem given to me by my sir as a challenge problem. So initially I began thinking using calculus, but really the calculus here, though answer will come, but it really creates a lot of complexity. So after closely looking at the terms, I figured it out that this problem has a very nice solution using coordinate geometry. How? Let me tell. So root of a square plus b square can be written as root of a minus 0 whole square plus b minus 0 whole square plus root of this term can be combined as a minus 2 whole square, and similarly we can write b square as b minus 0 whole square plus this term can be written as root of a minus 0 whole square plus b minus 3 whole square plus this term, entire term can be written as a minus 4 whole square plus b minus 5 whole square. So basically a comma b, this point, is the minimum distance from the points 0 comma 0, 2 comma 0, 0 comma 3 and 4 comma 5. So let's draw a simple coordinate plane. This is 0 comma 0, let's say this to be a, and then we have 2 comma 0, let's say this point to be b, then we have the point 0 comma 3, let's say to this point to be as 0 comma 3 c, and then d, let's say it's 4 comma 5, so over here 4 comma 5. Now a and point a comma b lies in this plane such that this distance from 0 comma 0, 2 comma 0, 0 comma 3 and 4 comma 5 is minimum. Now let's find out where this point a comma b would be. So theory, what is the theory behind this problem to proceed? The theory behind this problem to proceed is that let's consider a point x comma y and let's name it to be p, and another point q, let's say l comma m. So basically let's draw a line between them, l dash. This is a line l dash passing to them. But now in order to proceed further, I am transforming this problem. We need to first find a point p comma q on this line l dash such that is distance from x comma y and l comma m, sum of the distance from the point x comma y and l comma m turns out to be minimum. Let's take the point, say that to say this to be s, such that we need to find minimum of ps plus sq. That is, let's join this point. Now as we know that the sum of two sides of a triangle is always greater than the third side, so this distance will be minimum when s is collinear, right? Because sum of two sides of a triangle is always greater than third side. So ps plus sq should have the minimum value PQ, basically here. S should be here. So similarly, if we again go back to this problem, if I just join the points AD and BC, the point should be basically here, A comma B, the intersection of this line AD and this line BC. Now you ask me why this is the line. Let's say, using the same logic over here, let's say the point to be A comma B here. So for this line AD, this distance shall be minimum, I agree, but for this line BC, this will basically be a triangle. Understand it? Means, let's say the point A comma B to be another point, say E. If A comma B lies on E point, this will be a triangle, so that sum of distances CE and EB will be greater than CB. And in order to minimize this must be on the intersection point here X. So my friends, that's all for this problem. I've done this problem. Now I request you to get the value of A comma B and drop the solution in the comment box. I hope you liked my solution. Do subscribe my channel. Bye.